Talking about the next talk, it's by Barun on minimalism with respect to key to cloud security. So, Barun, all yours.
Hey folks, hello. I'm Barun Acharya. I'm here to talk about minimalism that would be key to cloud security. Why minimalism? Why minimalism is important in cloud security? That's all I will cover in the talk. But before that, who am I? I'm Barun Acharya. I work as a software engineer at Accuknox. I'm a maintainer of Cube that we talked about a lot in the past hour. I'm a CNCF ambassador. I've been associated with Google Summer of Code, LFX mentorship, both as a mentee and a mentor. I hang around at open source developers community, and I recently graduated, so I like to include that. So containers, we have been talking about containers from the morning. In the first talk, it was mentioned that Gartner said that 90% of the 90% of the systems will include microservices and containers based by 2026. So with that rise of adoption, it's important that we include that we talk about how do we secure them. There's been numerous vulnerabilities recently like Log4j, PwnKit, and a lot of them, and they can pop up anytime. Even if we try to detect existing vulnerabilities using static analyzers, there will be new vulnerabilities popping up anytime. So how do we protect against them and prevent them? Here's a sample Kubernetes environment that we have. We have containers orchestrated inside nodes, and these nodes have their own runtime, system packages, kernel. But there are a lot of gaps associated here. And malicious actors are always looking into these gaps to attack on them and try to affect your system somehow. But what we can do is minimalism. We try to reduce our attack surface based on at node level, at container level, minimize our container runtimes, reduce system packages, harden our kernels, such as that there's a lot less attack surface and attackers are puzzled to find out how do I attack your infrastructure. And that's what we will be talking about today. At what all layers, how do we introduce this minimalistic approach in our infrastructure? We'll start around with node images. Node images are your worker nodes where your containers execute, and they have a lot of data. A key thing to note is containers package all their dependencies on their own. You don't really need a lot of system packages or kernel features because most of the packages are packaged with the containers already. So why have a lot of packages on your node if they are not going to be used itself? And that's where minimal node images come into the picture. Most of the cloud providers provide their own set of images which are optimized for running containers as well, like container optimized OS by Google, Bottle Rocket by AWS, Rancher OS. But what features do they have that make them minimal? They have an immutable root file system. Most of the containers are writing, reading, all the operations are carried out inside containers itself or the volume mounts. Why have why have like why allow modifications to your host system? Similarly, reduce set of system packages because containers are already packaged with all the dependencies. Why do we need additional dependencies in our host system itself? And finally, hardened kernel. Features like integrity measurement architecture, secure boot, these, these try to maintain file integrity and reduce tampering of your system. Let's talk about an attack scenario. There's a malware by Rocky Group, which what it does is these are excerpts from like it's a huge malware which does a lot of things, but I have accepted some of the things that it does, which are prevented by these, which can be prevented just by choosing the right node images. So there's self-replication, that the malware is written to temp folder, then it copies itself to user SBIN directory, such as it executes as a super user process. And then it alters the modified timestamp to 416 days back, so as you don't think that this is something new which was added to your kernel, to your system, but it has existed from a long time. Then there's shared object injection. The GCC libc files are modified. If GCC is not available, it installs using yum or apt installs GCC and then compiles the libc files again. And finally, because nodes can go up and down, the malware needs to persist somehow. So they modify init scripts and inject such that like whenever the node restarts, the malware is active again. But by choosing the node image, we already have immutable root file system. So user SBIN directory won't be able to modify. So the process won't be available there. Then there's modification of GCC. Because of immutable root file system, anyway, the libc file wouldn't have been there. But because the system packages itself are not available, no one would be able to compile GCC. And then there's modification of boot. In these node images, the startups are signed, the grub is verified at boot using TPM such that any tampering made is detected and we use the existing thing to, so as the malware is prevented. But that was about our hosts. What about containers? We think that containers are a sandbox. And anything happening inside containers can do whatever they want. They are inside a sandbox, so whatever is happening inside them, we don't really care about that. But containers have a lot of accesses outside. They access certain privileged system calls, they interact with other containers over network, data storage. We talked about PVCs a lot in the morning. They access those PVCs. They have certain capabilities. So there's a need to reduce the gaps in the containers as well. One way to do that is reduce the packages here again. I'll talk about it in the next slide, but containers come with a lot of bloated system packages itself. Why would you need a PS command, PS utility in your container if its only job is to start a web server? This is so talking about reducing packages. The only intent of reducing the packages, not that why are we not using them, they are just increasing the container size, but they also come with the baggage of vulnerabilities themselves. So this is a chart prepared by ChainGuard, that this is the Python latest image which was scanned. It had the number of vulnerabilities are huge, and then there's a minimal version prepared by ChainGuard which has no vulnerabilities because it removed the unneeded packages. But this is only about existing vulnerabilities. Folks, are you aware of shell shock vulnerability? Anyone has heard about it? Shell shock is a vulnerability in Bash. It was discovered in 2014, but it has been in Bash shell from 1989. And it went undetected till 2014, and folks might have exploited it or not, but we came to know about it in 2014. But Bash looks like an innocent package in our containers, and we generally don't tend to. Anyone won't think that okay, Bash would have a vulnerability, so we would always package our containers with Bash because that's the de facto shell whenever we need to debug our containers. But a seemingly innocent looking package can come up with a vulnerability anytime. Today, a shell like certain package doesn't have any vulnerability. So the static analyzers would say that, okay, your container is secure and is protected against vulnerabilities. But 5 years down the line, your same container image will be vulnerable to some vulnerability which was discovered later. So how do we protect against that? How do we prevent that? That's where minimalism comes into the picture. Why include all those packages into your container? Reduce the number of packages that are required inside your container such that you don't like you can be safe today as well as be safer in the future, because you don't have to deal with like keep on scanning and be worried about I need to manage so many things. There are minimal set of things and you are protected against that. An example is cloud native applications in general today are Go applications, which are portable and self contained, statically compiled. All those features are Go specific. But why need an Alpine image or Debian image for starting those building those Go containers? The only thing that the Go container needs is the Go binary that you build. So any other dependency is not needed. So there's no need to include them. And that's how you can be minimalist with your images. What we talked about is how can we reduce our bloat inside the containers itself. But there's an aspect that these containers have access to outside entities as well. And we need to think about how to reduce accesses at that level as well. Kubernetes security context, which was talked about a lot right now. That's a way to enforce those things. Have seccomp, have capabilities, reduce your system calls available to a specific container, reduce the capabilities. Today, a lot of default contain when you run a container in the default mode, certain capabilities are still allowed, which might be seemingly safe, but because they are available, you can introduce. So what's the recommended way of going is you should drop all capabilities and allows only certain ones which are actually required by our container. Similarly, if you are in Kubernetes environment, these facilitate that. But if you are using a bare metal instance, you can go ahead and use Docker security options. Containerd and CRI have their own set of security options that you can leverage. There's proxy filters, service mesh, container networking interface rules, which would enforce which containers can talk to each other and have the access limited like that. There's a tool called Docker Slim, which helps you trim down what all file systems are needed inside your container and remove all the files which are not needed. So, and we already talked about this, but like how we talked about lightweight minimal node images, the base images of your container should be lightweight as well, Alpine and Wolfie. I talked about Bash right now, but Bash is something which generally comes inside containers by default. But if you had been using Alpine as your base image, Bash is not available by default. So you were protected by shell shock by default. Zooming out a bit, we talked about infrastructure, we talked about containers. But what about humans accessing those containers and interfaces? There's Kubernetes API, there's Docker API, there's different your accesses like production, staging, development. There's a need to enforce RBAC on that, role-based access control. Like who are the users inside your team that should be provided certain accesses? Like not everyone in your team needs access to production, not everyone in your team needs access to staging, so you should restrict like that. But talk about a scenario where this was where we came to know about the importance of this. Uber had a social engineering attack recently. So what the Uber like this is not their only security mechanism, but I have pointed out which was exploited by that attacker. So Uber had a perimeter security and around sensitive files that only folks inside their intranet, inside their VPN, could access all the set of files and things like that. And the VPN access itself was protected through multi-factor authentication. But the MFA was breached using a social engineering attack. So the attacker flooded a certain team member with a lot of MFA notifications, and somehow he ended up accepting one of them, and that's how the attacker got access to the virtual, like their private network. Now once he was inside the private network, they started scanning all the file system and finally found a file which was a shell script which had admin password to their PAM, and the PAM, that is privilege access control management, has all the secrets to all the services. So this the sole reason, like everyone in their intranet had access to this admin password, and then it was exploited by the attacker to actually gain access to all the services out there. So role-based access control was important here, that okay, even if you're inside your network, you need to think that not everyone needs access to this admin password. One can exploit this admin password, like someone outside can compromise your network and be inside your network perimeter, and then start exploiting things that you have allowed, that you think that only genuine users are accessing. So the question is, what if we are already compromised? Or to say, we should always think that we are already compromised. And that's what zero trust is about. Don't trust anyone. Follow the principle of least privileges, and always assume that your systems are already compromised and allow accesses to folks, like folks as in like even your team members, or we if like we talked about containers, inside containers, binaries, the networks, pods, it can be headless users, all the entities. You need to have a granular view of who should have access to what. Even inside your containers that we were touching base upon, so your containers have access to secrets. So even inside your containers, certain binaries like Apache would need access to secret for some reason, but SQL does not need to it. So this is where access control at containers makes sense, because volume mount is something which we think is mounted inside a pod, and anything inside a pod then can access it. But as we talked about earlier, a malicious actor can be inside your container already. From that aspect, if we enforce the policy that okay, only allow Apache to access this secret or volume mount, the malicious actor, even if he is inside the container, won't be able to access it. So how do we go about setting up access control inside containers like this? The first thing is you need to understand who all are accessing, like the sensitive assets that you are defining. So you need to set up observability to gain visibility into what your containers and your containers are doing. And to enforce that, you have Linux security modules, or you have user space interception methods like LD preload and ptrace. They come with the caveat that you need to understand their policy language or deal with the complexity of understanding system calls to orchestrate this access control. For setting up observability and gaining visibility, we have tools like Falco, Tracy. For Linux security modules, there's Kubernetes native security context, which allows you to orchestrate AppArmor rules, seccomp policies, SLNX labels. And then we already talked about, we have KubeArmor, which provides you with both gaining the visibility into what your container is doing, as well as translating simple YAML files to the Linux security models construct, be it AppArmor, BPFLSM, or SLNX. So to conclude my talk, minimalism is key to cloud security. But that's too minimal of a conclusion. I won't leave you with that. An elaborated conclusion is that there's a need for multi-layered minimalistic approach. You cannot just think that okay, I've already used a base image which is minimal enough. That won't be enough. You need to be minimalist with your base images, your containers, your accesses, access control inside containers, access control to your users, with all those things. And there's minimal node images. You need to set up perimeter around containers. This is how we talked about seccomp, network policies, service mesh policies. This help you set up perimeter around containers. And then there's a need to set up perimeter inside containers as well, like how we talked about only allow certain process or binaries to access and the privileged entities that you have. And finally, minimal permissions to all users to prevent social engineering attacks. So thank you, and open for questions now.
So, can we use cryptography for it?
Cryptography for, like, can you be more?
Like a zero trust security
Mhm.
for authenticate users.
As in, for authenticating users, like, your main need is, like, are you talking about public private key combination?
Yes.
Yeah, like the number of layers you want to add to protect things, it's up to you. You can use cryptographic approach, you can use MFAs have TOTPs, you can have, some folks still use SMS, which are not really safe, but they have things like that. So the efficiency of security is not the point, but the point is, like, you need to have that security in place, that okay, you need multiple approvals to validate. Yeah.
Hi. Uh, so I'm on our while we are building Dockers, we are using multi-stage builds. So like we build because some of them might not support Alpine by as, so we build it and we finally create an Alpine. So does this fall into the minimalistic approach what you suggested?
Yep. That's how it goes. Like, you won't have all the build utilities that you need in your final. Like, let's talk about Go binaries, right? So you would need Go and Go toolchain entirely to build your application.
Correct.
So you have the Go base image for that. So
Correct.
you build your Go image in your base layer, then copy only the Go binary to your final container.
Correct.
That's what multi-stage build is.
Yes.
So your final container only has the Go binary, and that's what's important. The final container that you have should be, that you're shipping to the users, should be like, should have the least number of packages.
Correct. Yeah, that's what.
I have one question.
Yeah,
Okay, I'll go.
I'll take. Okay.
So you said about that social engineering attack, right? Uber.
Mhm.
What could have they been done to prevent that? Like some basic security practices were there in place, right?
Okay,
Still
they are
happen.
they are Uber, so they obviously had a lot of security practices in place, but what they missed was that they included admin password in their shell script to probably ease out something. It was an overlook or something, but point was that that shell script was still out in the open. So what they probably could have done is, like, the first point was that they should have already obviously not kept password in an open file. So use secrets manager and fetch those over. There are a lot of places there. And the second thing was that, like, those files should not be available to everyone in there.
Organization wide.
Yeah.
Okay. Right. There was one more
Okay.
question. Right?
Yeah. Am I audible?
Yeah, I can hear.
Okay. So the presentation was good. What you said was okay. Use minimalism, like reduce the number of packages and stuff. But what you essentially put at the end is you gave a lot of security tools that does so many things. So you are not minimal on the security side of things. Now, is it possible to achieve 100%, like not forget 100%, 80% container security with just three tools max? Is it possible?
Okay.
Putting on backlog
I'm-
around.
I'm put on spot for this, but like I talked about this, right? Like, there are a lot of steps involved. Like, the first step was you should have a minimal node image. That's not a security tool. That's a practice that you should have. The second is the base images of containers. That's again a best practice. So all of it, like most of it, were not actually tools. Yeah, at the end I put a lot of tools which were there to ease your things. So, like, I talked about role based access control. It's hard to know, like, okay, not just limiting to you team members, but even inside applications, which application needs to access what entities, what should be the service account privileges and all that. So there are a lot of tools to automate and discover that things for you. We talked about discovery engine and ways to how enforce zero trust in a way. So like the tools are there to help you implement that. If you can take the pain,
No, no, no. So
right?
on security tooling part, I have seen multiple open source tools which are doing almost very similar, very similar things.
Exam.
I could give an example right away, right here with some of the tools, but like I guess Kyberno and what was that? OPA, Falco, Cilium, Tetragon, and what was the other one? Like QWarmer to some extent. So all of these are like all of these are pretty community oriented projects, which are pretty fabulous, but they are like doing the same things in different ways. Which means, as a person leading the product security team or someone, they do not know what exactly to do, like which tool to pick up, what are the advantages, and what they miss out if they don't pick the other tool. So that particular thing is what I see is missing. So there are so many things. Rancher has new vector. Trivi has a bunch of tools on container security. There are so many tools. Picking the right tool, what exactly we get out of container security, that is what I think is missing so far. So if you have any suggestion for that, I'm open. That would be great. Thanks.
I think I can talk about it. So sorry to chime in here.
Sorry, I'm from product security side only, so I have an answer for that. So you should not reduce the number of tool sets, but you should have a better vulnerability management system. Because today there are a lot of open source on vulnerability management system where it can even deduplicate. Like say you get same results from 3 tools, it can create one issue for you. So I can even share you that. So instead of reducing, say, okay, I just want to use one tool for this, bring in as many tools as possible, and maybe one tool can have more capabilities or more rule sets than others both. So we cannot today differentiate and say like, okay, all the 3 tools are running the same 100 rules. So my suggestion to you is like to build a good vulnerability management tool. That's my no. Why should we build more see, it's automatic, right? It's like
Be hard. So let me be straightforward. What I've seen in the past, I've used Defect Dojo, I've used multiple security tools which are open source. What happens is you get started with it. Maintaining that for your infra is like very hard.
yeah, we
That is what happened when we tried to do very similar thing. Get all the vulnerabilities to a single place, but that didn't work out for us.
yeah,
We moved backward.
yeah, we are using a tool called Armor Code, which can actually, which is really good. So, but yeah, if you reduce the tools, the coverage will be less. That's the point which I wanted to share.
Yeah, Rahul, can you also answer the same?
No, I would, say something in the context. One is, yeah, like you said, this is the real pain problem. A really big pain because you have so many tools doing slightly different things, and then as a user, which is one that you're going to pick. And to solve so many tools problem, now we are going to introduce one more tool which says that it's going to solve all of these problems. That's exactly what is happening, and that's what the journey that we are also on is, what I feel sometimes. Like let me acknowledge here, it's a big problem. Like this problem was there in other aspects as well, like in storage and other aspects. And I feel that a significantly different model has to be adopted for security. And that's where I feel that something like a storage operator is in place, which actually orchestrates your storage policies, where you specify that, as a user, I don't care I want a 2 GB or a 10 GB disk space with so and so criteria. As a user, I should be able to specify that. But under the hood, what is the engine that is doing? It should not be exposed to the user. That is what is missing, is what I we realized. But yeah, I don't think we have a clear answer today, and that's a gaping hole. Yeah.
So just to add to that, based on the Uber story that we heard, finally the eventual motive was to get hold of what's there within the secrets, right? And that is what is the like gateway to get into the rest of what is there in an ecosystem. So is this something like, let's find a way to get secrets out of Kubernetes, because end of day it's all base 64 encoded, right? And maybe look at something like HashiCorp Vault or something like that, where make it a lot more secure, out of and not keep. I mean, this is just, I'm like thinking out loud here, but is this where we need to head to? Because base 64 encoding is not going to solve our problems. End of the day, I don't technically see too much of a difference between a config map and a secret, other than that base 64 encoding, right?
Interesting part to the same point. Rahul came up with two use cases of securing the secrets manager themselves.
So
HashiCorp Vault.
the
and-
problem is, I mean, I think we can go into go, but I think we are derailing the
yeah,
agenda here. So
Yeah, maybe after the
yeah.
session we
Take
can
it offline.
Like CyberArk Conjure and HashiCorp Vault, both are breachable.
Absolutely. Yeah. And by the way, is your PPT template open source as well? I really like that.
Yeah, really good work, Barun. Yeah, can we have a round of applause for Barun?